Hi, pre-calculus students. Welcome to section 4.3b examples. How you doing today? Let's take a look at our first example. Given this triangle of with a leg of 5, right? So this is a right triangle, I should say, with a leg of 5. Well, that's supposed to be a right. There we go. Better. Right, with a leg of 5, opposite theta, and a hypotenuse, they're asking you to find the 6 trig values. So usually what we do is just find the first 3, sine, cosine, and tangent, and then take the reciprocal of that. Okay, so let's start with, first of all, it would be really helpful if we had the adjacent side to theta. So I'm going to do the Pythagorean theorem. I'm going to call this A for the adjacent side. If I square A plus I square the side of 5, when I add them up, I should get the hypotenuse squared. So I have A squared plus 25 equals 169. I will subtract a 25 from both sides. There we go. And A squared equals 144. So when we take the square root, that means A is a side of 12. That's a Pythagorean triple there, 5, 12, and 13. So let's go ahead and take our Pythagorean work here, and let's put in a side of 12. There we go. So cosine of theta is the adjacent side over the hypotenuse. Sine of theta is opposite over hypotenuse, and tangent of theta, which by the way is sine divided by cosine, just so you know, I'm sure we'll be looking at that, is opposite over adjacent, 5/12. There, now we can move on to find the values of the reciprocal functions. So the reciprocal of cosine is secant. So that would be 13/12. The reciprocal of sine would be cosecant. So that would be 13/5. And the reciprocal of tangent would be cotangent. And that would be 12/5. Now, if any of my sides has square roots in them, and those sides ended up in the denominator, I would be rationalizing that denominator, not because I want to, but because they do. Let's look at number 20. They give you that cosecant is equal to 9, and they want you to draw a triangle. So I got one going for us, and find the other 5 trig functions, right? So they gave us cosecant. Now, I know that cosecant is the reciprocal of sine. It is the hypotenuse, right, over the opposite side. So the first thing I could do is turn my 9 into 9/1, right? And I can put these sides on this triangle right now, but I think I'll just go ahead and also write sine then would be 1/9, just because I'm better at using sine, right? And so I'm going to label on this triangle the opposite and the hypotenuse from theta is 1/9, 1/9. Okay, the next thing I'm going to do, I'm just going to give myself a little room here, is I do need the third side of this triangle to get the other 4 trig functions. So again, I am just doing the Pythagorean theorem. And that would just be the hypotenuse squared minus a leg squared would equal the other leg that I'm missing squared, right? So just kind of doing the Pythagorean theorem, but with the information I have. So that would be 81 minus 1 is 80, is A squared. And I'll take the square root of that. So this side would be the square root of 80. However, that's not how it would show up. They would actually reduce the radicand. And what they would do is, sure, 80 is 4 times 20. And 4 is a perfect square. But there is a bigger perfect square in 80. 80 is 16 times 5. Right? And so I can take the square root of 16. That is 4. And I'm going to keep my square root of 5. So what you'll see them do is they will write this side as 4 square roots of 5. Okay, so let's recap. I did the Pythagorean theorem. I took the hypotenuse squared minus the side squared. I got that side was the square root of 80, and then I did a little work to reduce that radicand. Okay, I'm going to erase the Pythagorean work here. And let's write cosine. Right, the 4 that we're missing. Cosine of theta would be adjacent over hypotenuse. There we go. And this means that secant would be the reciprocal of cosine. That would be 9 over 4 square roots of 5, which is perfectly true, but they won't leave the square root of 5 in the denominator. They will rationalize it, and I will get 9 square roots of 5 in the numerator and 4 times 5 in the denominator. There we go. So right now I have cosecant, sine, cosine, and secant. Let's get tangent. Tangent is opposite over adjacent. Rationalizing again. And in the numerator, I have the square root of 5 over 4 times 5 is 20. And cotangent then. Now, for cotangent here, you may be tempted to take your correct answer for tangent and take the reciprocal, but if you do that, do you see you'll get a square root of 5 in the denominator again? So what we're going to do is, let's go back to our original tangent. Opposite over adjacent. Right? This was correct. It just wasn't rationalized. So if we take the reciprocal here to give us cotangent, then we don't have to rationalize. There we go. So sometimes it's better to take your original so that you don't have to rationalize the denominator twice. Let's go up. Our example was from 27 in the book. Given cosecant and pi over 6, they want the degree that matches pi over 6. And they actually want to know what is cosecant of pi over 6. Now they're asking for these things without a calculator, okay? And it takes practice. I am going to have you memorize the unit circle, which has pi over 6, which has tangent of a square root of 3 on it, right? So you will not be using the calculator to get this information. You will be memorizing this. So right now we're just doing our best with what we know. Okay, first of all, I do know when we did section 4.1 that pi over 6 is 30 degrees. How do I get that easily? Pi is 180, right? So 180 divided by 6 is 30. Now, what is cosecant of pi over 6? I don't know. I can't keep that in my head, but what I can keep in my head is sine of pi over 6. That's what I'll have you memorize. So I am going to write cosecant as the reciprocal of sine of pi over 6. Notice I don't take the reciprocal of the angle. Sine and cosecant are reciprocal at the same angle. You don't take the reciprocal of the angle. Now, sine of pi over 6, I happen to know is 1/2, and I'll teach you how to do that. You'll memorize the unit circle. And it turns out the quadrant, first quadrant from the unit circle is on your left hand, and I'll show you how to do that. In fact, I'll just do that right now. pi over 6. Here is 0, an angle of 0, pi over 6, pi over 4, pi over 3, and pi over 2. So you put your pi over 6 finger in. Cosine are the top fingers, sine are the bottom fingers. And it's the square root of the fingers divided by 2. The dividing by 2 doesn't have anything to do with your fingers. It's always dividing by 2. Cosine, sine, the square root of one finger is 1 divided by 2 is 1/2. So this is the reciprocal of 1/2, and the reciprocal of 1/2 is 2. Okay, find cotangent of 11 degrees, 15 minutes. This is obviously from my calculator. However, I don't have cotangent on my calculator. So I am going to take tangent of 11 degrees and 15 minutes. I'm going to take the reciprocal of that, and then that will be cotangent. So let's take a look. I'm going to check my mode on my calculator. There we go. And I'm going to type this in. So I am going to do 1 divided by, and I'm going to do tangent. And remember, I'm going to do 11. And where you get that degree measure is from second apse, which is angle. And you get the minutes in the same place. That is a single quotation mark. Here we go. And so here we go. Here's what I typed into my calculator. Sometimes you can see it. It's how the sun is shining there. Oh, a little bit. There we go. It's better at night in my home. There we go. Oh, I actually forgot to turn the lights on. That's fabulous. Is that any better? It's just not with the, there we go. A little bit better. Okay. And there we go. 5.027. There we go. Is cotangent of 11 degrees, 15 minutes. Now on 60A, they asked us to solve for theta. So we are answering in an angle, and they want to know between 0 and 90 degrees, where is tangent a square root of 3? Now, there's a few places to get that from. We did special triangles in section 4.1. And what we found was that at 60 degrees, that tangent was pi over 3. So you could get that from your knowledge of your right triangles. Okay. And I know how to write 60 degrees in radians, right? It is pi over 3 because pi is 180 and 180 divided by 3 is 60. Where else could I get this knowledge? You will memorize it on the unit circle, and it's also on my hand. Okay, again, this takes a little practice though. Don't think you have to catch on. Tangent is on the back of your hand. Sine and cosine are on the front. So if you remember, here is 0, pi over 6, pi over 4, pi over 3, and pi over 2. Now, when you put a finger in for your angle and turn your hand over, right, it will give you tangent. Tangent is the square root of the top fingers divided by the square root of the bottom fingers. So notice when I put in my pi over 3 finger and I flip my hand over, tangent is the square root of 3 divided by the square root of 1, which is the square root of 3. That's another way to get it. Okay, number 69, a mountain with a vertical height. This is supposed to be vertical. Now that I look, that doesn't look very vertical, does it? Yeah, it's a little better. With a vertical height of 1,500 feet, and you ski down so I was trying to abbreviate to save room, but you ski down, your path is 3,000 feet. And they want to know what is the angle of elevation. So if you were at the base of the mountain looking up at your path down, what would that angle be? Well, because we're trying to solve for an angle, we do know that we're going to use an inverse function on our calculator or from our head, right? And so I just need to know what trig function to use. Well, if you notice, I have the side opposite the angle theta, and I have the hypotenuse. I don't have the adjacent side here. I could get it, but why spend time, right? So this means I can't use tangent and I can't use cosine because I don't have the adjacent side. So I'm going to use sine. So sine of theta is equal to the opposite over the hypotenuse. Notice that this is 1/2. Okay. I'm trying to solve for the angle. So I'm going to do inverse sine of 1/2, and that's going to give me the angle. I will want to make sure I'm in degree mode on my calculator, not radian mode. So let's be careful there. So it's perfectly acceptable on your calculator, in this case, to do inverse sine of 0.5. And it gives you the angle is 30 degrees. Okay. But what I want you to know is I do know where sine is 1/2, right? Many problems like this, you do not have information that's on the unit circle, but here I do. Take a look again. First quadrant, 0, pi over 6, pi over 4, pi over 3, and pi over 2. Sine is the fingers on the bottom, the square root of the fingers on the bottom divided by 2. Okay, so if I put in the pi over 6 finger, it's a sine, cosine, sine. Sine is the square root of 1 over 2, which is 1/2. So that just happened to be on the unit circle. But you are welcome to use the calculator on a lot of these. They will not turn out to have values on the unit circle. So I hope you enjoy getting back into trig. You did that in geometry and algebra too. And it's so useful and fun, and I hope you find it is too.